Hello, my viewers. This is another presentation of my lesson 22 density PU form formulation below the sea level. Always mind this. These are the keywords below the sea level. We have this same formulation in terms of at the sea level. We also have this formulation in terms of above the sea level. There are different things there. Polyethylene foam generate gas. That is the internal gas generation. We also have external gas generation. That is the air pressure. So the air pressure plus that of the PU foam interact is going to undergo change in the chemical reaction in terms of foam expansion. You understand? Because it is this gas CO2 that is generated as a result of reaction between TDI and water enable the foam to expand. Now, this expansion, the level amount of this expansion depend on external air pressure. You get me? So this is how it now affect this at different level. Are we all together? Now, I decided to use 22 density water blown formulation. And I did say that, at higher pressure, gas is compressed. At the lower pressure, gas do what? Expand. Okay. So at the sea level, you are at the baseline, okay, to choose your formulation or parameter that will give you those density that you desire to produce. Anyway, there are ways of troubleshooting all this one. There are ways to correct them so that they will not affect the reaction. But the issue is that when you are setting formulation, you are using 22. We choose at the sea level because the reasoning that we were able to predict the formulation variable, because we are not responsible of the atmospheric pressure. We are only responsible for the environment, because the raw material temperature, we can control it as a foaming engineer, okay, and make sure that it's constant throughout your production process. Now, below the sea level, what happens? Below the sea level, if you are producing a foam density below the sea level, the pressure that is acting on a pressure, okay, it will make the gases become heavier. So the foam will be struggle to rise. You understand? So the gases will be too heavy in so that is acting. This is a force that is acting on that foaming system. So in that case, gas will expand less. It will restrict the expansion of gas, making it for some of what we are running we will be struggling with the block height, not because something is not working, because of the change in atmospheric condition that affect the entire system. So the question, if I experience this, what should I do? I did say that someone can use different part by water to achieve the foam density. Take a look at this one. At the sea level, 4.55, right? Above the sea level, we have 4.2 to 4.3, right? Then below the sea level formulation, you need to have 4.7 to 4.8, while polyol still equal to 100. That is the baseline. This enables you to accurately scale up your polyol. This is a global convention of formulation, designing a formulation, PU formulation technique. So look at what happened. So these are the effect of altitude. That is the factory location, the change in this location in your factory premises. Now, what happened below the sea level is that the gas will tend to be restricted, thereby acting on the foam. So what you need to do, you take this water. Remember, all this one they are all foam density of 22. Please. They are all foam density of 22. They are all foam density of 22, but at the different level. Okay, so this shows that the gas, the foam will be undergo less expansion. The foam will undergo more expansion because of the availability of gas. Gas is not restricted here. Gas is restricted here. Here is normal, so it can take charge here. So now you see these gases, you know, the amount of these gases, okay, how they expand foam, okay, depends on a pressure of the environment. So that is why in the introductory part I just said that someone can say, I use this, I achieve this, correct. I use this, I achieve this, correct. I use this, I achieve this, correct. It's all depending on the change in altitude of the factory location at which they are running that 22. Whether you choose to use MC, whether you choose to only use water blown foam, this is what you are going to experience. In this case, what I normally tell people that when you are running extremely low density, you find out that the foam will rise at above the sea level, and when the CO2 release, the foam will come down. Wow. In that case, if you are wise enough, you will not increase, you will not allow the blowing catalyst supersede that of gelling catalyst. So you have to do it in reverse. Make gelling more than blowing so that to correct this in foam density. You understand? So most of the time when you experience this in your factory, don't just assuming that the pump is not okay. This is not okay. These are the secret attack of PU foam reaction. You know, chemical reaction is very sensitive to the pressure, to the concentration, to the temperature of the environment. So they are not working together. One is trying to interfere with the reaction, but you should be able to put this into consideration and control it. So this is how change in atmospheric pressure affects what? A PU foam reaction. That is the altitude, so that whenever you listen at the sea level, you need to put this into consideration. Thank you for watching. Continue to share. Like my page, subscription is free. My viewers, thank you so much. I hope this is very, very interesting. Thank you. Bye.